Okay, very good.
It's soft.
Very soft.
Oh, it is. Not bad.
The one?
Yeah. So our first presentation will start at 6:30 only. So we have prepared some refreshment outside for you. Feel free to help yourself. And the restroom are straight on right before the canteen on the right hand side. Yeah. So feel free to hang around networking, and we start again at 6:30.
Test check 1.
Welcome to the Cloud Native and AI Meetup today. Thank you very much for being here. My name is Hồng Phúc Đặng from Force Asia. For those you who haven't heard about us, actually I see a lot of familiar faces. Good to see you again. For the past 15 years, Force Asia has been advocating for the adoption and development of open source in the region. Our work includes develop open source software and hardware and organizing events like this. You probably know us by the Force Asia Summit that happened many years here in Singapore. We do hackathons, workshops, and meetups similar to this, focusing on open source technologies, not only in Singapore, but also in many countries in the region, Vietnam, Indonesia, India. We also have some events in China. And today we are very happy to partner with ByteDance Open Source Program Office, Shopee, of course, and also Đạo Cloud to bring together to you a program that highlights open source tools people can use to run and manage their cloud native applications. For today, we have 4 presentations, and each will last around 20 to 25 minutes, followed by 5 minutes of Q&A. We have prepared some present here for you for people who ask questions. Wait, not only for people who ask questions, but who ask great questions. Yeah, interesting question, or share any example that you use from your company, any ideas that you can share. The present are here waiting for you. What else? We are streaming this event online on the Force Asia platform, LinkedIn, YouTube, and also X. If you have any friends who could not make it here today, you can share with them to check out online. What else I want to say? The restroom, I already mentioned that before, right outside, straight on, right before the canteen on the right-hand side. Yes, and without further ado, I would like to introduce our first speaker of today, Jerry Cheng from Dow Cloud. He is the Director of Strategic Development in Architect at Dow Cloud. He will talk about the open source journey of cloud native AI. Jerry, are you ready? Yeah. Okay, please welcome Jerry.
Hello, can you hear me? So good evening. Good evening. Thank you for everyone to be here. And my name is Jerry from Dow Cloud. And now I'm the Director of Strategic Development overseas and also ecosystem development. So today I will share with you the open source journey of cloud native AI. Okay, so my session will divide into 4 parts. The first one is the introduction to cloud native AI and the introduction to dark cloud. And the second one is the overcoming challenges with open source innovations. The third one is highlighting the key open source projects dark clouds initialized and contribute to the community. And finally, I will show you some future directions of cloud native AI. So I believe that many of you here may be one of the roles showing in these slides. Maybe you are the architect of hardware of infrastructure. Maybe you are a platform engineer. Maybe you are a machine learning engineer. Maybe you are a business person who want to leverage AI to solve the problems. So maybe you already familiar with the words cloud native, such for example, container, microservices, service mesh, immutable infrastructure, and so on. So this technology already being widely used in industry. So what is cloud native AI? This table shows the challenges we faced in AI. As we know, in the predictive AI era, maybe the model is small, the data maybe not very large, and the storage, the network, the computing requirements may be low. But in the generative AI era, the model can be very, very large, maybe more than 10 billion parameters. Maybe the storage can be 100 TB. So maybe you need thousands of GPU cards. So we need the cloud. We need new technologies to solve these problems. What is cloud native? Cloud native AI is referred to approaches and patterns for building and deploying AI applications and workloads, and using the principles we already used in cloud native, and we enabling this repeatable and scalable AI focused workflows allows AI engineering to focus on their own domain. Thank you. So now I will introduce Dark Cloud. Dark Cloud was founded at the end of 2014 and in Shanghai. And we set up our Singapore office in 2022, 2 years ago. And now we are an innovative leader in the in cloud native field and also in application modernization field. And we are dedicated to deploying open cloud OS to our customers, to the enterprises to seamlessly achieve digital transformation. Maybe you are familiar with the logos showing on the right part of the slides, such as Kubernetes, Istio, maybe etcd, maybe Prometheus, maybe Hubble, and the number on the right corner of these logos are the ranking of dark clouds. So now we are the third. We ranked number 3 in Kubernetes community and ranked number 2 in Istio community. And now we have 2 CNCF ambassadors, one Kubernetes steering committee, one Istio steering committee, and 2 members of Cloud Native AI work group. So we joined the Cloud Native AI work group last year, and also we joined many other groups in the Cloud Native Computing Foundation. So, this picture shows, as we know, many large language modeling created every month. You can see GPT-2, GPT-3, GPT-4, 4.5, maybe GPT-5, and also many other language models. In every week we can heard that big news in the large language model about large language models. So we may know that if you want to deploy generative AI, you want to deploy a large language model, you need many GPU cards. You need to buy the GPU card. You need to invest many. So this is just the surf on the top of the iceberg. But there are also many other challenges we can't see under the water. Such as we need the specialized workforce and the long-term cost. We need to solve the network and the data storage problems. We need to focus on the privacy security and also data risks. So these challenges across the machine learning processes, from data preparing, from feature prepare, from model training, from model storage, and to model serving. So this tree diagram shows the challenges we may face in when we want to use cloud native AI. So there are many challenges from data prepare, model training, so the model serving, about user experience, and also from the cross-cutting view, we can see many other challenges. We need to solving the data security problems. We need to leverage observabilities to the cloud native AI technologies. So what dark clouds doing to solve these problems. We mainly focusing on these 4 parts. The first one is computing power resource. Second one is a high performance network. The third one is computational task scheduling. And the last one is data storage accelerate. So we initialized many open source projects to solve these problems, and also we contribute to the community. For example, Hami to solve the computing power scheduling problems. The Q project to help distributed scheduling, and the Spider Pool to accelerate the network, and the Huame store to accelerate the local storage. So we are to the these projects are all open source, and these projects created by Dark Cloud and contribute to the community. For example, is job queuing controller. K-Walk is large scale cluster simulation clusterpedia to help the developer to search the resources in multi-cluster. The Huame store to accelerate local storage, and other projects. And later I will give you a quick introduction about this project. K-Walk is an open source project to help us simulate clusters, multi clusters in low resource requirements. So you can use this project to simulate maybe 100 or 1,000 clusters, maybe a cluster with 100 or 1,000 nodes to help you to simulate the situations maybe you faced in the production environment. So now K-Walk has more than 2,000 stars, 1,000 committees, and more than 60 contributors. Also, K-Walk already by Dark Cloud, Tencent, Huawei, Red Hat, also ByteDance, and IBM, and other famous companies. The second project is Q. Q is a CNCF landscape project, and this project is a job queuing system for batch HPC or AI or machine learning workloads, and we help to do the job scaling in these scenarios. And also this project was adopted by famous companies like Google, like Shopee. And also this project was co-developed by Dark Cloud and the Google team. Spider Pool is a underlay and RDMA network solution for the Kubernetes. And this project is a CNCF sandbox project. This project can be used to help to accelerating the network in the Kubernetes project. And Huame store is also a sandbox project. And Hami is a vGPU solution, and it's an open source project, and it's already being used in DAO cloud projects and also in for paradigm projects. So by using this project, you can divide GPUs into many slices. Then you can get many small GPUs to run your workloads. And Classpedia is also a CNCF sandbox project. You can use this project to search resources in multi-clusters, maybe more than 100 clusters. You can search deployments, search any other resources in these clusters. And also Cubing, and also Data Tuner X. Data Tuner X is a newly created project, open source project. So till now, there are only 84 stars. But if you are interested in this project, you can use this project to do the fine tuning, the model solving, and also other tasks. So we leverage this open source project to provide advanced solutions to our customers. The first one is DCE 白泽. DCE 白泽 is a AI computing platform for our customers to combine the heterogeneous GPUs to provide the multi-tenant billing and also observabilities to the GPU cloud, and the customers can use this platform to train their model, to do the data preparation, to serving this model to the end users. The second one is D.run. D.run is an open platform, and you can open your browser, type in the D.run, and it's a real domain. You can visit the website to try if you interested with these capabilities. So finally, so I introduced the many projects we created and contribute to the community, and what are the future of cloud native AI. So I divided these features in 4 parts. The first one is recommendations. We need to focusing on the custom platform dependencies, flexibility, and sustainability. And the second one is evolution solution for AI and machine learning. So maybe you are familiar with Kubeflow, vector databases, and also open large language model metering. And the second one is opportunities. Opportunities, you can you can visit the CNCF website to find many interesting projects about cloud native AI, and also maybe cloud native AI can give us many new engineering disciplines, and also we need to pay more attention to the trust, to the safety, and the last one is AI for cloud native. I talked many about cloud native AI, but how we can do how we can leverage AI for cloud native. So maybe we can use neural language interface for cluster control. Maybe you can ask questions to the Kubernetes how many ports in the cluster, or how can I do to upgrade the workloads in the cluster. So you can ask any questions to the clusters. So maybe we can leverage large language models in the Kubernetes and also in security area. Maybe we can ask cluster, how can I do to improve the security in the environment? Maybe the cluster can answer that you need to deploy API gateway to protect your APIs. Maybe you need to deploy port scanner to scan your workloads to find the problems in your environment. So we can integrate many AI capabilities to the cloud native technology. So thank you. Thank you.
Thank you, Jerry. We have time for 2 questions. Any question? So to get things started, how about I ask a question? So we can also get present. It's really interesting how many open source projects and downloads released to the community. So if anyone can name one open source project that download created, get them. So I see 2 male and then 1 female. How we give it to the female first?
Oh, Hami, right? Correct. Hami.
Correct or not?
Correct.
Correct. So do you want to ask her what is the project about, or is it?
Maybe it's difficult, but it's delicious.
Okay. So maybe you can give a reference to our.
Thank you.
Any question, or should I ask another question?
You go question.
Okay.
Okay, so Jerry, please, how many hands you raise your hand again? Question. Okay, please give one person who you'd like to take. Okay. So the question not really interesting, right? Not be try in order to get. Okay.
So I'm just saying that I'm very much interested in Kubernetes and I do a lot of AI stuff as well. My question is, when you said that there will be AI for Kubernetes, and I saw a lot of interesting stuff there, but how are you going to do that? Like, for example, if I want to know what will be the routing, for example, if I am getting a noisy neighbor situation, so can I ask that with AI chatbot, AI powered chatbot, that is it there, and how can I resolve that? Is that the case?
So your question is about AI for cloud native.
Right. I saw a project that you're working on, right?
No, actually, our projects mainly about cloud native AI. AI for cloud native is our direction. So in Dow Cloud, we already deploy internal knowledge base about the Kubernetes operation, about how to deploy, how to maintain the Kubernetes. So our engineering can ask questions in this internal system.
No, that's fine. Like, that's a knowledge repository bot that you're talking about. But I am more towards that's the static stuff, right? I'm talking about a dynamic situation where there is a problem inside the cluster, and I want to know what is the problem and how can I resolve that. Can I do that? And
you can do that. But you need to prepare the data, prepare the questions, prepare the answers, and also you need to train the model the normal normal data, and maybe it can find the abnormal data.
okay, so ideologically, you are saying that there will be a source system for the monitoring and real timing it will be
Yes.
fetching the source from the source. It is going to in a landing zone, data landing zone, and then you are performing queries on that. That's correct.
Yeah.
Okay. Thank you.
Thank you.
So I think that is actually a very interesting question.
Oh, maybe it's
The audience will know any open source like monitoring on the cloud out there, open source solution to monitor your pipeline or something that you use in your company.
Yeah, if we do, I can tell.
So what do you use?
So there are different things in security. For one is there is DevSecOps pipeline. So we monitor check marks or other tools we use for that.
But
But
I don't think your is open source.
right, but you can do that. The open source version is also there. If you're not going for the paid version, so you can do that. It will give you a very detailed PDF. Right?
Where do you work?
I work at a consulting company that does network technologies. So we are mostly into HPCs and AI and data stuff. So that's where I've implemented DevSecOps pipeline. As well as if you talk about the normal security, then it's like I've implemented zero trust. So different endpoint securities, and top to bottom, what will be the firewall, and how you are going to control the traffic.
Okay. Interesting. Thank you very much for the question. Thank you, Jerry.
Thank you.
For your insightful presentation. And with that, I would like to invite our next speaker. So we have unlocking the potential of all how Kubernetes with Micro by that review from finance.
Hello. Hi, everyone. Thank you for being here. My name is Gary. Right. Okay, thank you. My name is Gary. I'm a software engineer from the scheduling and orchestration team at ByteDance, and I'm very excited to share with you a tool that we have built internally and we use internally, which is called KubeEmerald. And the title of my talk is called Unlocking the Potential of Multi-Cloud Kubernetes with KubeEmerald. So as I said, I'm a software engineer in the orchestration scheduling team at ByteDance, and I focus on building large-scale cloud-native infrastructure. And to give you a head start, I will share with you a little bit about how we use Kubernetes at ByteDance. And for those of you who are new to Kubernetes or haven't used Kubernetes for a while, I'll also be recapping some key Kubernetes concepts. Okay, so Kubernetes is an open source container orchestration system that was open sourced by Google, and it automates the deployment, scaling, and management of containerized applications. And since its launch in 2014, Kubernetes has seen widespread adoption in many large companies and small companies alike, and it has become the de facto container orchestration solution. Many companies are using this and has basically become the cloud-native operating system in our age. Right. So you might ask, why is Kubernetes so popular? Right. So these are the key points that has given Kubernetes so such widespread adoption. Right. First, it automates your deployments. So Kubernetes allows you to define how your application should be deployed and what resource it needs. It then automates the process of actually creating the containers and managing the necessary infrastructure. Right. So you just have to declare what you want and how much resources you want to dedicate to your workloads, and then it automates away all the hassles that you have had to deal with when you were using bare metal deployments or maybe VM deployments, right? So second, it's very feature complete. It comes with many features out of the box, including, of course, container orchestration and also many value-added features like service discovery, load balancing, and configuration management. So it's a whole package that helps you manage your cloud-native workloads, right? And third, it's declarative. So you just have to declare your configurations, and you don't have to worry about how your configurations will be materialized. The Kubernetes system will take care of that for you. And with that, you can easily reason about the states in your cluster and let Kubernetes help you achieve your desired state. right? So this is a brief overview of the Kubernetes architecture. As we all know, Kubernetes is a system that manages a cluster of worker nodes, right? So it has this this central control plane, or also called the Kubernetes master control plane, that has a few components to help you orchestrate the workings, the internal workings of this Kubernetes system. And of course, it manages a lot of worker nodes. Like here on this diagram, I have shown two worker nodes, worker node 1 and worker node 2. And on each node, you can run many of your containerized applications in Kubernetes terminology, we'll call it pods, right? And each pod will manage maybe one or two or even more of your containers. And how will a user interact with the Kubernetes cluster? You can use official or third-party UIs, or more for us developers, we will more likely to use the CLI called kubectl to interact with a cluster. But of course, Kubernetes API server exposes a RESTful HTTP endpoint with which we can interact with it very easily. So how do you deploy an application using Kubernetes? You will specify a YAML manifest, including your which tells Kubernetes what you want to deploy. So this will specify your application name, your application, the container image that you want to use, and how many replicas of your workload that you want to run. Right. So here I'm running an Nginx deployment, running Nginx, and it's using Nginx 1.14.2, this image. And it also tells Kubernetes to expose port 80 so that we can accept incoming traffic. And you just have to submit this manifest to Kubernetes, and it will automatically create a lot of internal objects, and eventually it will create your containers. It will choose the best worker nodes to place your containers and run the containers there. And yeah, so it's basically a system that automates the entire deployment workflow of your workloads. Right, so onto the cloud native journey at ByteDance. Since 2015, we have started using Kubernetes to build our internal cloud compute system. And from 2015 to 2019, we'll call it the first stage, we focused more on building the basic capabilities, like we built our internal microservice cloud compute platform using Kubernetes. And in the second stage, from 2019 to 2021, we focused more on scale and resource efficiency. As our businesses grow, the number of machines and the scale of our workloads increased tremendously. And so that's when we adopted Kubernetes Federation based on Kubernetes v2 for microservice orchestration. And as I will touch on later, Kubernetes Federation v2 was basically a precursor to kubeMRO. And from 2022 to now, which is the third stage, we focused more on open source and diversification, as well as the features of our internal systems became more and more complete. We wanted to give back to the community, and we also wanted to diversify from just managing microservices to managing more types of workloads, including batch processing jobs and maybe serverless workloads, etc. Right, so onto multi-cloud and multi-cluster Kubernetes. You might ask, who needs multiple Kubernetes clusters, right? A Kubernetes cluster already manages thousands of worker nodes, so why do you need so many clusters, right? So these are 4 key reasons why you need multiple Kubernetes clusters. The first is scale limit. A single Kubernetes cluster, by the official recommendations, can only accommodate 5,000 worker nodes. So if your businesses grew so quickly that you need more than 5,000 worker nodes, a single cluster can no longer satisfy your needs, right? So, and the second reason is that the second reason is fault tolerance. With a single cluster, if your cluster goes down, all your workloads are in risk, right? So with multiple clusters and having your application spread across many clusters provides fault tolerance when a single cluster fails. The third reason is about locality. Having different clusters located closer to users can help you reduce the latency of applications. And the fourth reason is to avoid vendor lock-ins. So by staying vendor agnostic, by using a multi-cloud cluster federation system, you can you don't have to be locked into a single Kubernetes cluster vendor, right? So yeah, you retain the flexibility to choose the best service provider. Maybe the provider that gives you the best set of features, or maybe it's just the most cost effective. Right. So how do you use multiple clusters then? Without any automatic tool to help you, you will have to use it to interface with these many clusters manually, right? So maybe you have AWS Kubernetes clusters, you have 5+ Kubernetes clusters, and maybe on the bottom you have on-prem Kubernetes clusters that you have built in-house. And with so many clusters, you will have to submit your workloads individually to each of these clusters. And this is a very laborious process. And when something goes wrong, you will have to, there's a lot of room to go wrong. Right, so it comes with a lot of mental overhead. With so many clusters, you'll have to go through the additional trouble of choosing the right cluster to deploy to. And it has operational overhead. The users will have to repeat the deployments for each cluster, which is burdensome and can lead to some inconsistencies. And the reason is about resource inefficiency. So when you have multiple clusters, your resources are basically separated into different pools, and these pools are not connected. So when you deploy something to cluster 1, the resources in cluster 1 cannot be shared with cluster 2. So when your resource 1 is full, or when your cluster 1 is full, you will have to manually migrate some of your services from cluster 1 to cluster 2. So this comes with some operational overhead as well. Right, so onto kubeMeral, the next generation Kubernetes cluster federation. So kubeMeral helps you to manage all the complexities of dealing with multi-cloud, multi-cluster Kubernetes federations. And it is the next generation Kubernetes cluster federation engine aimed at addressing the aforementioned pain points. And it was initially based on the open source project KubeFed v2, and it has been used at ByteDance since 2019 and has evolved significantly ever since. All right, so at ByteDance internally, kubeMeral manages dozens of Kubernetes clusters, manage a wide variety of workloads, including microservices, batch jobs, and serverless workloads. And on top of kubeMeral, there are and each day there will be more than 30,000 deployments. With this scale, we are able to support hundreds of millions of active users from the most important mission-critical workloads at ByteDance. All right, so kubeMeral basically gives you multi-cloud Kubernetes minus the headache. Firstly, it allows you to overcome the limit of single cluster Kubernetes. It allows you to run more than 5,000 nodes in a single resource pool and benefit from the cross-cluster rebalance and fault tolerance. And secondly, you can easily migrate from single cluster Kubernetes to kubeMeral because kubeMeral provides a compatible API with the single cluster Kubernetes. And thirdly, kubeMeral is very configurable and extensible. It has very flexible scheduling policies and very flexible resource propagation policies, which exposes a lot of knobs for you to turn. And fourthly, it's very extremely performant because it has been battle tested at ByteDance. All right, so let me walk through some of the typical use cases of kubeMeral. The first use case, kubeMeral allows you to manage cross-cluster workloads. So previously, you had to interface with each cluster individually, but now you only have to submit your workload to kubeMeral once, and kubeMeral takes care of propagating your workloads to the different individual member clusters. And the users are presented with a unified view, resource pool, and you don't have to deal with the complexities of so many Kubernetes APIs. And the second use case, kubeMeral gives you flexible cluster level scheduling. So each of your member clusters might be a little bit different. So some might be located in the Singapore region, some might be located in Malaysia, and etc. And besides topology, maybe some of your clusters can support, this type of workload, and another cluster can only support a different kind of workload. So this means that your clusters more most likely will have different kind of characteristics. And so kubeMeral gives you the ability to schedule workloads based on the different cluster characteristics. Right, so in this example, I'm scheduling a workload that wants to be deployed in SG and MY, maybe for locality reasons to reduce latency, and kubeMeral will interpret this workload to generate the cluster selector, and it will and this cluster will take effect when scheduling the workload to different member clusters. And the third use case is about dynamic replica distribution. So when you run stateless microservices like an Nginx or maybe your application, your API, you will usually run multiple replicas of it. All right. So kubeMeral allows you to distribute this many replicas across different member clusters. And it does this by considering the resource utilization levels, the actual utilization, real-time utilization levels at different member clusters to achieve a balance between the different, across the different clusters. All right, so in this example, we have 100 replicas that we want to distribute to the member clusters. And we see that member cluster 1's resource utilization is only at 30%, and member cluster 2 is saturated, and member cluster 3 has 70% utilization. So kubeMeral will intelligently schedule these 100 replicas to cluster 1 and 3 by proportion, whereby 70 are scheduled to cluster 1 and 30 are scheduled to cluster 3. So by doing this, in the long term, when you have many workloads and many replicas, it helps you to balance out the resource utilizations of different clusters automatically. And the fourth use case is about cross-cluster failover. When one of your clusters goes down, kubeMeral can automatically detect this situation and migrate some of your workloads to the actual healthy clusters. And the fifth use case, which is a little bit advanced. So as I talked just now, kubeMeral has this component called a scheduler that helps you to place your workloads in different member clusters. And this scheduler is actually very extensible. It has many extension points. So during the scheduling stage, a workload will go through 4 stages: filter, score, select, and replicas. And each of these stages will be an extension point where you can write different plugins to customize the behavior. Right, so you can filter and score clusters based on certain criteria, for example, geographical topology, tenancy, quality of service guarantees, resource utilization, etc. Right, a few advanced features that have yet to be open source, which are respecting rolling update strategies across multiple clusters. So when you also make sure that anytime the next number of unavailable replicas will exceed your threshold. And second is about deletion. Works similarly to the PDB object, if you're familiar with it, in a single cluster. And thirdly, we support sharded cluster federations. So the kubeMeral controller can be deployed as a sharded component. And with this, we can support even larger workloads, even larger clusters. Right, so I talked about in details about kubeMeral, but kubeMeral is actually just one of the projects in KubeWolf. KubeWolf is the enhanced Kubernetes toolkit open source by ByteDance. So there are a lot more KubeWolf projects, and all of these are open source, and most of these, including kubeMeral, are included in the CNCF landscape. So we have kubeBrain, which is a high performance metadata system for Kubernetes. It is an etcd drop-in replacement. And we have Kube Gateway, which is traffic governance for Kube API server. It allows you to configure your rate limiting and strategies for different types of resources and different, which is a lightweight multi-tenancy solution for Kubernetes. It achieves multi-tenancy using a lightweight namespace-based protocol and gives users the logical view of many different individual clusters, which are actually just based physically, which are based on a single physical Kubernetes cluster. We also have Catalyst, which is a resource efficiency toolkit for Kubernetes. It has defines a set of quality of service requirements, and it allows you to mix your online and offline workloads together to achieve cost savings and etc. And we have Gödel Scheduler, which is a unified scheduler for both online and offline pods. It has a set of very complex placement strategies whereby, well, if you're interested, you can read up on it. We also have Telemetry, which is a Kubernetes global control plane tracing system. Yeah, so if you're interested, please visit our website, try our Kickstart, and give us a star on GitHub. And yeah, with that, I'm happy to end my presentation. Thank you for your attention.
Any questions from the audience?
Yes, it's not.
I just checked out the GitHub repository. I noticed this is currently supported 1.24, the version Kubernetes. What is the plan for upgrade? Like currently in our company, we are using 1.26 and our so.
Well, technically, we do support. So the reason we support only up to 1.24 is because of certain APIs, certain native Kubernetes APIs that have been deprecated since 1.24. So if you try our Kickstart, there will be a few built-in configuration objects that only works for 1.24. But the key capabilities of kubeml can technically support all the future Kubernetes versions. We just haven't had the manpower to test out the newer versions.
The second question I have, like, what about like I see there's some command which can has a CLI program which can take over like multiple clouds. But what about the visualization, graphics? Can we have like is there any servers which UI provide all the service can
Thank you. That's a very great question. So actually, if we go back to one of the previous slides, so kubeml exposes a Kubernetes interface to you. So basically, you can interact with kubeml host cluster as if you are interacting with a single cluster. So all of your UIs and your third-party solutions where you can visualize the cluster objects can be used on top of a kubeml cluster. There will be some caveats, but I'm happy to guide you through.
Any other questions?
This lady.
Which one do you want?
This lady raised her hand first.
You choose that. Okay.
Question might be the question that I like to know about what is the difference between Jenkins and Kubernetes? Because I used to use the Jenkins for automation my business. So do you think I can apply Kubernetes for my automation as well?
Well, I have to apologize because I'm not very personally familiar with Jenkins, but maybe I'll try my best to answer. So kubeml is a Kubernetes cluster federation system. So it allows you to combine multiple individual Kubernetes clusters and presents you with a logical view as if all these clusters are glued together to form a huge cluster. So maybe if you're familiar with single cluster Kubernetes, you might get what I mean. But I'm not sure how. I haven't used Jenkins personally myself. Yeah, I'm sorry.
Jenkins is a CI
Right. Yes. Yeah. So yeah, Jenkins is a CI/CD pipeline, but I was thinking maybe you can have some Kubernetes backend for Jenkins or something. Yeah. Okay. Thank you. Anyway.
Yes, so
Yeah. Sure.
So I just want to mention the present actually sponsored by Group. If you just see now, this is an organization by PIDA, a collection of different open source projects to manage scalable cloud infrastructure. How many clusters actually they are running in PIDA?
We have about 500 clusters.
How about Congo? Okay. Okay, good. So yeah, so thank you very much, Mary. I think that's all the time we have for this presentation. And anything else that you'd like to say? Yeah, so check out the organization people on GitHub. I saw that you have a GitHub link. The slide will be shared online at the end to all of you. Yeah, thank you very much. Next, I have Nicolai from Coffee. So the topic is this is how we adopt passive reinforcement models in FinOps.
So just press down. This button, right? Okay. Right. Yeah, I see there's a lot of people. Right. Okay. My name is Nicholas. I'm a platform engineer from Shopee. I'm actually part of the engineering infra team that develops quite a lot of solutions for handling resources in our clusters. So a bit of a background of this company, Shopee, which is actually an e-commerce company with products that service multiple regions like Taiwan, Singapore, Indonesia, and Brazil. And then we are also the #1 shopping app in Southeast Asia as well as Brazil. And we have the highest number of monthly active users also in countries such as Brazil for this category. Now, enough about the company background. Actually, we have a lot of pods running on our clusters to support such a large-scale application. Currently, we have over 100,000 pods running across data centers across the world. But you have so many pods running all over the place, and you also need machines to run them as well. And you have a lot of machines, you also need to spend millions of dollars on this hardware. So as part of FinOps, another thing we need one thing about is the cost of this hardware. If we can improve the efficiency of our resources, we can fit more containers on our physical machines. We don't need to buy so many machines. In fact, we might even be able to reduce them. So that is the crux of FinOps. So as part of this sharing, so I believe the topic is theme is like AI. So how does AI come into here? So actually, AI, a lot of people think it's ChatGPT, is LLMs, and so on. But actually, there's a lot more to AI. It's actually, there's machine learning as well. And machine learning can be used to predict things. So in this sharing, I was share about how we actually make use of these technologies. Now, first, we want to understand how can we improve the resource efficiency. We also need to first figure out where are these resources wasted. So we have a few areas where we have identified which are major sources of resources. So in Shopee, we usually have to handle things like campaigns. So for campaigns, we usually have a very large spike in traffic, but then this spike doesn't materialize in every other day. So, but you still have to keep these resources in reserve. And a lot of our machines in Shopee is on premise, which means we also have to keep quite a lot of unallocated resources as a emergency buffer to handle these campaign requirements. We also have a fragmentation problem. So you notice we got a lot of memory left over. It's because a lot of our applications, stateless services tend to be more compute intensive. But actually, this also results in our machines having a lot of memory that is just not being used. And yeah, our campaigns can easily be double, triple the traffic of a normal day. So we can have quite a lot of gap in the utilization between the normal day and the campaign day. But we still have to handle those campaign days. Is the user, if they see app malfunction on campaign, the experience is not so great. So we need to spend some budget on that. Another thing to consider is that there's also differences between, let's say, the peak period. Like, let's say, during lunchtime, more people use the Shopee app. Versus, let's say, someone is sleeping. Then maybe there's some people that still use the Shopee app, but not as many as compared to the peak period. So now that I've covered on the resource wastage, we can identify that there are some resources that are just not used. We have the unallocated resources because we need to keep some for campaign or emergency users. We also have some that is unused. So I think these resources are allocated, but our applications are just not using the full set of resources. So we have all these resources that are sitting around, not doing anything, and no one else can use them. Also, maybe your up, but actually we can actually feed them with something else, which are like things like batch services. So imagine you can use all these unused resources, unallocated resources, and magically you now have a few 100,000 CPUs that have materialized out of nowhere, and you can now run other things such as your big data and video transcoding. So what are these batch services? They are those services that can handle toleration. I mean, they can tolerate evictions, and also they can handle throttling. And they actually, one special trait is that they can handle reduced availability, which is a key trait of these services. Because without this ability, you can't really feed them into these spare idle resources, because the amount of idle resources can change over time. So if you can reduce availability for these services, you can feed them into the periods of the peak periods. For peak periods, these resources, idle resources might not exist, perhaps. Yeah, then we just let the online resources prioritize the resources for them. Then during off-peak periods, we can just let the resources go to the batch services. Then for your online services, there are your normal stateless services, your stateful services like databases, and perhaps you also have a model inference, which is also considered an online service. Now, running both online and batch services together on the same physical resources sounds easy enough, but actually it's not so simple. One thing is that we want to place these batch services on the idle resources. So it means that idle resources can increase or decrease over time. But yeah, when you increase and decrease these resources based on the things like CPU usage, you might see evictions that occur frequently. But if you evict your batch resources every like 1 minute or 2 minutes, they can't do any real work. So it means we need to do something a bit smarter about this problem. And then also some of our batch resources, for example, Presto, they have some penalty if you kick it out of the machine. Because if let's say your Presto pod or process gets killed, your user's query may need to restart from the beginning. So usually we'll have a shutdown period of about 60 minutes, which is actually quite long. So we have all these problems, but actually we have also solutions for them. That's where forecasting comes in. So what are the forecasts that we look at is we have two time windows that we consider. One of them is short term, is where we are focused on actually trying to reduce the volatility of the resources. So you may notice when you go up and down resources, every time the idle resources goes down, we need to kick out some batch resources. But sometimes maybe this down may be very short-lived. We can probably tolerate temporary reduction, just throttle the batch processors a bit longer, and they can probably survive this temporary bump in search of the resource requirements from online services. Then you have the long term, which is focused on the trends or seasonality or cyclical patterns. So what are these kind of long-term trends is, for example, it can be, actually long-term might not be that long-term. It could be as short as within like maybe 1 day. Within a day, your lunch period maybe has higher usage. Then maybe it goes down during working hours, and then it goes back up during evening periods, and then goes back down during the night. Yeah, so these are patterns that we look for in long term. And these patterns can also extend beyond 1 day. It could be weekly, it could be monthly, it could even be based on holidays, like annual occurrence. Yeah. Then, so what's the purpose of long-term forecast is that we want to actually avoid placing these pods into places, the physical nodes that actually might have a high probability of eviction or throttling. So how do we actually do this forecast? First, we'll take a look at short-term forecast. Remember, our objective for short-term forecast is to reduce the number of evictions. So actually, one thing that we want to try is to reduce the number of non-essential evictions. So we only want to evict when actually there's a genuine resource pressure and not just some temporary change. So we actually make use of some statistical methods such as moving average, or in this case, it's an exponentially weighted moving average. The main difference between the normal moving average is that this one is focused towards reaction, more quicker reaction to recent changes. Then what's the point of using a moving average is that we actually want to make the changes a bit more smooth. So outliers or basically noise will get a bit softened. We don't need to evict every time the trend goes down, or unless the trend changes significantly. That's where the confidence band comes in. Then, but this short-term forecast is not so useful for a long term because your moving average may be a bit too slow to react if you need to actually figure out 1 hour ahead. So we need a long-term forecast. So, but let's imagine we have this long-term forecast. Let's say exists. So what can you do with a long-term forecast? So let's go back to the case of Presto. So for Presto, remember that if we evict the Presto pod, the user's queries will have to be restarted. They throw away a few hours of computation, which is a waste of resources. But if let's say we know ahead 1 hour later, 1 hour in advance, that this machine might have a surge in resources, there's a good probability that this Presto pod will need to be kicked out. So we can actually evict this Presto pod. We can signal it eviction 1 hour in advance. So this Presto pod can get to run for the next 1 hour safely before it needs to be removed. So this one allows us to run this Presto, ensure that the queries will get completed on time, because we actually probably know roughly what is the length our users' queries tend to run for. Then, so how do we do the forecast? Is first that we actually need to understand what's the background metrics for our input data to this forecast function. So you may think that okay, forecast, I just take the past nodes utilization and then just copy it to the next days and so on. But actually, no, it doesn't work that way, because in Kubernetes you can add or remove pods from the nodes. So we need to actually break down the resource utilization into what is the constituents of this node. For instance, the node can comprise of online services. You may run multiple different services. Each of these services have different characteristics. Then you also have the batch services that also contribute load to the machine. They should be isolated from the online service usage. Then also, we have these daemon services, which is actually your container D, your kubelet. They also take non-negligible amount of resources. They contribute to the background usage of this node. Then, okay, so then now that we can break down each of these the nodes utilization into the individual components, so we can forecast them, each of them separately. But what kind of things are we looking for in the forecast? Is that so for CPU usage, there's actually a repeating pattern. So one of them could be is based on the user's activity. So maybe some periods of the day, there's more users concurrently using the application, so the CPU usage is higher. Then sometimes it could be actually not caused by user. It could be a periodic function. Maybe you use salary beat. It triggers every 5 minutes. Then your CPU usage may spike every 5 minutes. Yeah. Then otherwise, there's also a case where your service multiple regions. Different regions have different time zones. For example, in Singapore, we have a GMT 8. Indonesia, we have GMT 7. If your service is service both Singapore and Indonesia, you might see a peak, one at midnight for Singapore and another 1 a.m. in Singapore time. But actually that one, the 1 a.m. one is actually the midnight of Indonesia. Then you also have seasonality. Weekends is a pattern that repeats every 7 days. And then you have campaigns, we have 9, 9, 10, 10, 11, 12, 12, and so on. They repeat every fixed interval. And then you also have holidays, which also roughly repeat every fixed interval, with the exception of a handful in Singapore. So then, so I talked so far about what are the patterns or what kind of characteristics we have for our utilization. Then how do we go about forecasting it? So actually, one thing to know is we know that our CPU usage is probably derived from the user's patterns, user's behavior. So the user's behavior is also has a pattern, which is kind of like daily routine. So maybe one simple way is that we can just copy the previous day's data. So actually, surprisingly, it works well enough that actually it looks like a fairly decent forecast. Yeah, you just take 24 hours ago, and then you get the next day's forecast. So nothing wrong with that, right? Actually, maybe it's actually true. Maybe nothing is wrong. But I'll go back to that later. Okay, so but anyways, we also have some things that we need to take care is that sometimes the world is not perfect. We may lose data along the way. Most of our metrics collection is through Prometheus, and how Prometheus works is that we crawl the metrics, we scrape them periodically, and sometimes this endpoint may just be dead. Yeah, so we lose metrics for certain periods. So we need to make use of some data imputation methods, and we can just get few. So this is just pure statistics. And then after we got this data, we can find that our data is quite noisy. We got a lot of random spikes here and there, which actually could be due to how we collect the data. It could be sampling related problems. So, but we can actually smoothen the data a bit. We can use moving average. We can also use a Fourier transform in this case. So let's say if we use Fourier transform, we can just use math, convert from time domain to frequency domain, and then this noise will be represented as low amplitudes, which we can remove through a low pass filter. And then you get back your smooth output. So this allows us to clear out all this noise from our forecast, which will allow us to improve the accuracy a little bit. Then another problem is that let's say you use multiple long-term forecasts. Then there's a problem is that let's say you run forecasts like maybe you predict tomorrow. Then when tomorrow comes, you need to predict for the following day. But then if you try to join this forecast naively, then you might sometimes see a phantom spike or a phantom dip. It's because your forecast might not be that homogeneous. It might not transit that smoothly to the next one. So we also need to take care that we also we need to do some linear transition between the forecasts. We can do this by overlaying different forecasts with each other. And then, so I've talked so far about forecasts. And at this point, we now have some sort of a long-term forecast that we can use. At this stage, how can we use this forecast? So let's go back to the scheduling problem. So remember that now I know what's the usage pattern of the services. I can guess what is the nodes utilization based on what pods currently exist on this node. By extension, I can figure out what is the node's utilization in the future, maybe 1 hour later, and can figure out what's the peak utilization that might occur in the next 1 hour. So let's go back to our problem for, let's say, Presto. If we want to figure out whether if this Presto is safe to run for the next 1 hour before it gets kicked out. So we can actually predict in advance to say, oh, okay, we see for this example, the utilization might go up in maybe 30 minutes or 40 minutes. Then, yeah, we need a signal to the Presto pod that, yeah, it might be a bit unsafe. Let's just try to do a shutdown right now. Then, yeah. So how do we actually build all of these forecasting pipeline? We can actually make use of data processing. So remember I mentioned our metrics actually come from Prometheus for majority of our services. So we actually have all this data. So containers we can collect from CAdvisor. The nodes you can collect from your node exporter. They all go to Prometheus. And then from Prometheus, we can actually export them to Kafka. And then this Kafka, we can just transfer them to an ETL pipeline into a Hive table or some other data warehouse form. Then from now that it's in data warehouse, you can do some data processing on it. So we make use of data pipelines such as Spark through Hadoop. Then we can call a forecasting function, which is actually usually implemented as a user-defined function. So in this forecast function, we can write some custom code to figure out, okay, so I got this input time series. Then I can come out some output time series that represents the forecast. So let's suppose that if I go back to the past few slides, we use a naive with all the slide enhancements. Yeah, we can implement all this into the forecast function. And after that, we got this forecast. What do we do with it? We still have to take care of the Kubernetes part, right? So we have a Kubernetes scheduler. We have a custom plugin to pull in this data from our Hive tables, although it's through a caching service, so we don't hit the data pipe, the data warehouse a bit too frequently. And then inside this Kubernetes plugin, the plugin has, okay, the scheduler has a multi-stage pipeline. So amongst these stages, one of them is a filter stage, which allows us to select which nodes should or should not go through this the scheduling selection. So let's say we now know some nodes may have some risk in the next 1 hour. The filter stage could discard these nodes. So that's how we can make use of the forecast. But so far I've mentioned it's a very simple forecast, but actually there could be some ways to actually improve it. So actually there's some problems with our very simple model is that it's too simple. it doesn't react that quickly to trends. So if let's say your service utilization changes a lot, then your forecast might be a bit incorrect. And then also, because a nice model, it takes in, it's based on information on the past, whatever data you put in. So it means that if you want to consider longer seasonalities, you need to put in a much longer time period, which you have to do this ad hoc each time you want to calculate the forecast. So this is not great because you need to push a lot of data into your pipeline, which will also make your pipeline slower and more expensive to compute. And also another point is that you cannot pre-train this pipeline. So you need to feed all the data upfront whenever you do a forecast. So maybe our model is too simple. Let's try other models. So in the industry, usually the use of statistical models is quite popular. And one of these models is Prophet, which is an open source model from Meta. So if you can see from the graph, actually the Prophet model performs a lot more better compared to our naive model. In fact, it can handle the trends more quickly. And the error, the MAE actually did reduce significantly. So yeah, it's doing something. But there's a problem with Prophet is that it's actually quite a complex model, and it takes quite some time to actually calculate the results. So perhaps one service, it might take about a few minutes to compute. But if you need to calculate tens of thousands of services, it might take a few hours, which means your forecast might be a bit late. So Prophet, better accuracy, but slower and quite compute hungry. How about other more popular ways, like machine learning? So machine learning is quite popular now. We can use it to forecast stuff. We can use it to do LMs. We can use it to make chats. And we can use it to forecast time series. So we have a lot of different models that actually are applicable for time series. I'm not going to go through all of them. You can read out the research papers individually. Yeah, so but let's say we want to start with machine learning. We need to figure out what models to use, and then we need to figure out how to train them. So our time series is actually just data. The machine learning models take in data and transform it to some output data. So our data in this time series could be represented as a tensor, but the format of the tensor depends on what kind of model you use. For instance, if you use a transformers, then you need to include a positional encoding to consider the seasonality. Or if you can use a simpler machine learning models like RNN or even the linear models, then yeah, they could probably consider the relative ordering of the features in the tensor. Then yeah, you have your model. The next step is you try and train the model. You need to collect a lot of data. You need to make sure the data is clean enough. And okay. Then yeah. Then you have packaged the model, and then finally you can do model inference. Okay, but big models they are a bit expensive to run. Then we have some approaches to do this. You can do quantization, spider windows, and yeah, this will allow us to feed the model into memory. And how do we fit all these data, all these new technologies into our forecast pipeline? You notice that this is actually almost the same as the earlier pipelines, which is whereby we change the forecasting function and to make use of machine learning. So we have PyTorch to do our model training, which can be decoupled from the pipeline. We can train our model on GPUs. Then once you have the model ready, you can do a model inference. Then after that, everything else is the same. And between the models, notice that the two graphs looks almost the same. It's because the machine learning model is actually fairly decent at predicting the results. And actually, you can predict results faster than Prophet. So it's actually not bad for its performance. So I thought about the different approaches that we use. So naive model is very simple, but accuracy is not so good. Prophet accuracy is better, but it costs more compute. And machine learning, the main problem in machine learning is that you need to spend a lot of effort in training the model. But otherwise, once you have your model is ready, after many hours of investment, then yeah, you can use a model to do inference quite quickly, and its performance is fairly decent. You can run the inference on CPU, depending on how small your model is. Now, I thought about so far about using all these models for collocation, but actually there's other ways we can use. Is that we can actually improve oversell. So traditionally, oversell is whereby you set your request to be smaller than the limit. But in reality, it's not so smooth. It's because our SIE sometimes they are a bit risk averse. They may give too much resources. And sometimes applications, they may optimize it over time, but they actually don't change the quota, even if the application uses less resources. So how can we deal with this is that, remember, I got forecasting. I can use make use of this utilization information, and then I can derive the request and limits. Then also, we can have services of different time zones. We know the profile in advance. We can also slot different services of different time zones together. This can improve the density of our applications. And I mean, density of the resources used on our physical machines. And then also another creative way to use forecast is through historical metrics of our services as well as the nodes. And then we can once we have the knowledge of these historical metrics, we can do forecasting. And we have found that machine learning is viable for forecasting. And forecasting can allow us to open new solutions that involve some foresight of the future. And that also allows us to react more quickly to changes that might be imminent. Yeah, so I guess that is all for I have for this sharing. I hope you all can take away something from this.
It's time for questions. Do we have any questions from the audience? So how about you behind you?
My understanding, the workloads on a node is what changes a lot every day. Because the upper workloads are not dedicated to this nodes. So my question is, why at the very beginning the analysis of the traffic and the forecast are focused on those instead of like a couple of nodes or a cluster or a few clusters?
Okay, question. So actually within a cluster itself, the nodes utilization is actually not even throughout the whole cluster. Some of them may have higher usage, some of them may have lower usage. So actually we want to avoid putting all these batch services or like big data services into the nodes with high usage. But how do you know which nodes have high usage and which ones actually will continue staying have high usage? Then also forecasting is to consider a problem where maybe sometimes nodes with low usage might actually become nodes with high usage later on. We also want to avoid putting our colocation resources on these nodes as well. So this is where the forecasting becomes important.
Okay, so any other questions? Nicholas, why don't you? Any other questions?
Let's see. Anyone from here or over there?
So please raise your hand.
Okay, never mind. Raise your hand again. Okay, one person only, 2%. Maybe the one nearest to me.
Yeah, since your forecasting is based on past data, right?
True.
Have you considered using some manual input to that? Because I can
yes.
see how
Indeed.
some of the events are not like in past data, like they can be like new events, like as you mentioned, like a promotion coming from the marketing team or something that is happening something that is new this year. Like you could mark that period of time as a marketing, like as a promotion, and then use some promotion model to actually predict that part.
Okay, you have actually pointed out something that actually skipped in the slide. It's due to time constraints. Is that actually you can actually introduce covariates to the model. So these covariates can include things like future events. So you can actually predict with improved accuracy. You can consider things like okay, we know that this day has a campaign, so it probably have a different utilization profile. We can feed this as a covariate to the model, and you can probably tweak its output based on this information. So this is how you can factor in future events into your model.
We have time for one more.
Oh, there. That's why you always didn't get chance, so we give them.
Going back to the slide with the one with the table, with the table and the machine learning versus this one. No, sorry, the one. Actually, no, yeah. Sorry. Here you mentioned that machine learning for you to forecast becomes feasible. I'm assuming because the forecast accuracy is important enough to incur those additional infrastructural costs and training costs, right? Because when I see them in red. Machine learning, yes, we have accuracy pretty high, but we have two red flags in a sense, whereas the naive, yes, forecast is not that bad, but it's moderate. So, whereas all the other factors are good, would you still consider moving to machine learning given the additional costs?
Yes, in fact, we already did that. Yeah, yeah. So actually, it's a foregone conclusion that we already moved to machine learning. So you may notice that actually machine learning got more red boxes. So it means maybe subconsciously you think machine learning is bad, but actually it's not. It just means that you have a quite a high cliff you need to overcome before machine learning becomes viable. So most these one is cost. You actually need the GPUs. You also have a lot of data. By extension, you need many GPUs, many machines, and also time, manpower. All these are costs they need to surmount before machine learning becomes viable. Of course, nowadays there's a Hugging Face. People put models like Chronos and so on. Then yeah, okay, and not saving quite a bit of cost if you use those. But if you build a model from scratch, then yeah, these costs you have to pay upfront. You pay with research time. You pay with electricity. You spend running a model. You pay time to collect this data to feed to your model and also to clean up the data for this model. Yeah. But once you clear that, then you already have a model. The compute cost, doing the inference itself is quite okay. It's not so bad. You can and the accuracy is can compete with Prophet. So Prophet is quite nice to use because everything is pre-tuned, everything is pre-built for you. You run it, you get result. That's it. The only problem is that it takes a while to run. Yeah. Then, but for machine learning, most of the thing is upfront. It's a training cost and so on. Yeah, like one-time cost versus repeated cost.
Right, thank you.
Nicholas, thank you very much.
Okay.
I just want to mention that you see on your screen, Shop they are hiring. So if you are interested on Shop opportunities here, scan the QR code. Yeah, thank you very much. So next we have our
on a RAG-based LLM application. I'll be explaining what RAG is, and at the end of the session, we will be running a chatbot on your own machine. Yeah, thanks. Right. Let's get started. So why we use Wasm-based large language model? Right. Okay. But before that, we want to talk about the open source LLM model. Why we previous slide, please. Yeah, thanks. Right. So you can, as from the chart, you can see that as time goes by, the open source LLM is getting better and better, and it's catching up to the closed source LLM. Next slide. Thanks. Okay. Right over here, you can see the Llama 3 70 billion is as good as Gemini 1.5 Pro. And over here, there's MMLU, which stands for Measuring Massive Multitask Language Understanding, and is clocking quite a good performance. Next slide, please. Right. Why we use the open source model? Because open source model is as good as OpenAI. In fact, you can get extra privacy, full control of your data, and lower startup costs. But currently, we do have a problem that we want to fix. And next slide, please. Right. Yeah. Yes. As one, you can see the pictures taken from the keynote, and that's the CEO of the WasmH, and I'm actually speaking as a community user of WasmH. You can see that there's many CPUs out there, hardware devices that we are targeting, and these hardware devices may need to build a different Docker image. Next slide, please. Next. So on the right corner, top right corner, you will see that the PyTorch official Docker image is quite huge, and the CUDA images are about several gigabytes, like 8 gigabytes and stuff like that. At the bottom of the image, you can see that Wasm file is very small. It's about, if you include the runtime, it could be just about less than 30 MB. And it runs well on Raspberry Pi and Jetson devices. It runs on full native GPU accelerator support that we can use to leverage on for our LLM applications. More importantly, it's cross-platform friendly. It runs at native GPU speed on NVIDIA, CUDA, Apple M chip, and ARM NPU. You don't have to have this physical device before starting building your own applications. Next slide, please. Next. Right, Llama H is a project built on top of Llama C++ and WasmH runtime. So there's no Python dependency. It's very small and lightweight. It is only Wasm file compiled from Rust language, and it's simple to deploy and develop. And this software supply chain is short. We don't have any other dependency, hence it's more secure. It supports a wide range of LLM, including vision language model, which recognizes image and text. No more pseudo, because you don't need to assign privileges. And Lambda H actually makes it very friendly to developers who want to integrate with OpenAI APIs. Next slide, please. In short, Llama H is an open source developer platform that aims to help developers to come on board the journey of cloud native AI. Here are some of the use cases of Llama H. You can use it to fine-tune a model. As we see that training a model is very expensive. You can just spend a little effort to fine-tune it. You also can use it to create your own knowledge base and run a chat bot services on your own. Okay, here are the steps that we will quickly run through. It's very short. You just have to go and use this single command line to install the Llama H. Yep. Next slide. Yeah. Thanks. Here are the steps. Just basically install WasmH runtime, download the model, download the portable Wasm file for API server, run the API server for the model. Thanks. If you don't like the UI, you can change the UI, change the web UI to make it more fanciful. Thank you. Yes. Okay, so now we'll talk about building RAG-based applications. Yeah. Okay, so traditionally, the user will send a query to LLM, like what you do on ChatGPT these days, and you get a response. And building an LLM is very expensive. So currently on the right, you see that there's applications of the RAG-based applications. So basically, yeah, on before the user makes any query, we prepare a knowledge context beforehand. We have several documents. The WASM Age, you can use WASM Age to generate embedding models. What is embedding models? Remember, machine learning is an n-dimensional classification methodology of finding correlations. WASM Age runs a WASM file to attribute elements with mathematical vectorization, and then help us to save it into vector database. Next slide, please. Next. RAG, retrieval augmented generation, is the full name of a term for the RAG. Can actually solve hallucination problem of LLM by attaching domain-specific knowledge. What's hallucination? Hallucination is basically the AI LLM model overconfidently give an answer which is factually wrong. Okay, next slide, please. Yeah, thanks. Okay, so we also like to introduce GaiaNet. GaiaNet is a developer tool which is a partner of WASM Age to build RAG-based application, and is built on top of Llama Age. And here are all the specifications which I will not go through. Thanks. Okay, so if you have if you have a phone already, you can scan the QR code, and this will bring you to the Llama Age documentation. And if you have a laptop, you can actually get started. Okay, I'll play a YouTube video. Yeah, thanks. Thanks. All right, I did it yesterday. There may be some unexpected results, but let's try and watch. So on the right, you can see the documentation. I'm just copying and pasting the documentation in the command line inside. So you install the WASM Age, and then here you do put down some binaries, call it here, and chatbot UI and stuff like that. Yeah, and here it downloads the Llama 3 7 billion model, which is which is very huge. But I think I'll just skip it. Yeah, I just skip it. I just copy it from some directory. And what we have now. So there's an embedding model, copy and paste, and you just download it. Good question. I'm just learning it also. Okay, the embedding models vectorize the to the vector database. But chat model is the one that helps the understanding of the natural language. Yeah, am I? Yes. Okay, thank you. All right. So what we have here is just sorry. Yeah, sorry. I think we played. Yeah. So yeah. So we are going to. Yeah. Can you back a bit? Sorry. Back to. I was interrupted. Sorry. Okay. Right here. So pause. Pause for. Oh, wow. Thanks. So here is preparing the steps of prepare the vector database. So we are using the QDRAM storage and QDRAM snapshots. And here's just a Docker commands to start the databases. Okay. Thanks. All right. Here there's this clears the token collection things, and we just throw it in anyway. And just copy and paste. What's this? Let me see. The knowledge-based snapshot, but we are not downloading a snapshot. I'm going to build it, the snapshot right from the computer itself. Yeah, and I go into the, what is it? Yeah, let me just, continue. Yeah, I think here is the steps to initialize the vector database. Okay, so, yeah. Okay, now the paragraphs, pause again. Sorry. Yeah, the important thing is the paragraph embeddings. Right. So basically, we talk about the documents itself, right? What we do is we need to write some code to actually vectorize it to the vector database. So basically, here's the kind of text processing, and it's WASM. WASM is basically using Rust to compile it. Yeah, and it's called paragraph embeddings. Maybe you have some, maybe other things like markdown embeddings and whatever. But this is just paragraph to, they call it paragraph. Yeah, please continue. Thanks. Right. Yeah, so once I did that, what do I have? Yeah, this is the documents that I'm trying to understand. So it's called Paris Chunk. It's actually a tourist guide text. I just take it in and I just do a cat of what this paragraph is. Okay, so I'm trying later. Ask some questions over here. I just will try to test whether or not the LLM the response I'm getting from the LLM actually is domain specific as for this text document. So I'm searching for some percentage thing, and later we try to get the correct percentage. What am I doing? Yeah, maybe I'm asking what's the percentage of the workforce is tourism related, and here is 24.4%. Okay, no, 12.4%. Okay, later we'll try to get this number. Yeah, yeah. So what I'm doing here is I'm doing the embedding now. Yeah, and then it's very fast. It's okay. Yeah. What am I doing now? Okay, it's playing. Sorry. I'm reading a document because I also just learned it yesterday. Yeah, so just yeah. So here is to put it to the vector database, which is a snapshot. Yeah, create a snapshot. Right. Okay, it takes some time. Yeah. Oh, thanks. Okay. Right. So I'm going back to the server side RAG LLM document. Yeah, and yeah, I'm skipping this step of the collecting snapshot from outside. I'm using a local one, so I just copy and paste inside. Okay, it's gonna pause a while, please. Thanks. Great. Yeah, so I hit the error. So actually, there's a typo in the documentation. So you see that you see like -PLL and llama 2 chat. Actually, I should be using llama 3 chat. So if you look at the documentation today, right now, right, it's been fixed. Yeah, I just tell the developer. So I basically hit some error. So it will affect my response later. So I went to go and search for other older documents and continue. Yeah. And yeah, this is where I'm finding some. Basically, I wrote the command somewhere, and maybe I added some as a wrong parameter, which is I added prompt template, which is not required now. Yeah, so and I get it working already. I get it working. So it basically is listening at 8080, and localhost 8080 is something like a OpenAI chat web GUI. So I will just ask the questions again. Yeah, the response may yeah, maybe you'll see a response not so good, but yeah. So what am I doing now? Yeah, what am I doing now? Right. I'm trying to look at the Paris chunk again, the document again, and just to show you, I'm looking at the 12.5%. Yeah, total workforce. And, oh yeah, by the way, the QR code is basically the tutorial page. And I'm typing. Sorry, this here you can fast forward a bit. No, as in like speed up a bit. Sorry. Yeah, okay, it's enough here actually. Sorry, yeah, faster a bit, it's okay. Okay, I'm enlarging the web GUI because it was too small. I'm actually typing the questions. It's just that it's underneath, you cannot see it. Right, come on. Typing. Right. Okay. Yeah. I'm just asking, what's the percentage of workforce in tourism in Paris? Yeah. Ooh. Okay. You can get 12.4% of the workforce. Okay. So the answer is 12.4%. So you see, like, gibberish, right? It's because I use the Llama 2 chat, which is a chat model which is wrong. I should be using Llama 3 chat, and you should get a clean answer. Yeah. Okay. Yeah. I think that's all for the demo, and I got last part is probably talking about, yeah. Let's continue. Right. Container tools to manage LLMs. Basically, WASM Edge is actually standing substitution for a Docker image in a large extent. So you can actually run WASM Edge on Kubernetes. We tried it before. And you can, yeah, and basically, yeah, over maybe you can look at the bottom, right? The Linux container image and WebAssembly app image, right? So whatever knowledge you learn about Kubernetes can be applied to using WASM Edge in your runtime in the Kubernetes. Okay, please continue. Thanks. I think I finished, close to finishing. Yeah. Yeah. Here's the resources to learning Llama Edge. Yeah, with this our end the slides. Yeah. And here's the QR code for my personal Twitter account. Yeah, so I might be organizing more hands-on workshop on WASM based related things in Singapore. Yeah, thank you.
Any questions for Alan?
Hi, Alan. Second time meeting you.
Thank you.
I'd like to ask you about the WASM page, right? What is the minimum? Let's say if I don't want to see GPU, what's the minimum Intel CPU I need to use?
CPU, wow. I think it because I mostly run on MacBook, so I think Intel should work, but I do not know exactly. Sorry, about hardware stuff. Yeah. Yeah.
Maybe someone else have the answer.
Yeah. Maybe someone else. Okay. This gentleman, please. Yeah. Yeah. Wait. Hold on.
Can I check? Because I mean, Llama.cpp and Llama connection. So I am able to run it on Windows x64 and ARM machines. So what's the advantages of using this WASM Edge? Using WebAssembly on top of this, because you add an additional layer of OS.
All right. Basically, for people who don't like to write C++, so you can write Rust to compile into WASM and yeah, use this. Yeah. The extra benefit. Good questions. You're saying let me think. Well, it's for other people to get started more easily, I would say. At the end of the day, like you said, it's still underneath the hood is using Llama, right? So, yeah. Yeah, thanks, sir. Right, right. They have tested it on it. Yes. Yes, because it's small. That's the thing, right? The WASM file is small. It's about, like I said, 30 MB and stuff like that. You compared to a Docker image, and you'll find that Docker image may not be very suitable. Raspberry Pi is not very suitable in running a Docker containers. It's for those very small devices. Thank you.
We actually have a question online on the stream. Thank you very much. So, Alan, the question here is: can we use all the model or 5.2 version of all the LLM for Llama Edge?
Yes, I can see it, but I think. All right. Oh, this one. I'm sorry, I don't have an answer. Yeah. I'm very familiar with Wasm H, but as for the machine learning, I'm not very familiar. So sorry. Right. Yeah.
Any other question from the audience here?
So I think Wasm primarily was meant to be like it's called WebAssembly, right? So it's meant to run in the browser. Is it possible? What you've shown just now is to run it both as a backend service as well as run it in Kubernetes. Is it possible to run the entire thing just service on the client side within the browser?
Right. This question, unfortunately, not. Yeah, because Wasm in the browser is very different from Wasm runtime in native. Like example, the web is using the web workers and stuff like that. And native wise is different. But then there's of course projects that try to merge things together, like they call it maybe Wasm Bridge and stuff like that. So for me, I'm doing games development on Wasm. So basically, the game Wasm file can run in a browser and it runs a game and it can run on native. And I'm also working on Android also. So for the Wasm Edge runtime, it's not possible to use Wasm Edge runtime on the browser. Yeah. But other runtime you may find is possible. Yeah. Okay, thank you. Thank you.
So thank you very much, everyone. I hope that you find something useful today. I would also like to thank our speakers for their time and for their contribution. Before we finish, right, I want to shout out to ByteDance Open Source, Shopee, and also the Applaud. Not only that you go organize the event, but for your contribution to the open source world. It's so good to see that companies not only use but release the project to the open source ecosystem. On the stream, our next meetup is gonna be next week on Thursday, July 18th. We will talk about mastering microservices with open source technologies, and it's gonna be at FinTech Hub. Okay, so if we would like to take a group photo, so you don't need to do anything, just sit there for about 1 minute. So set the camera. So okay, so our photographer, what do you want us to do?
I need everybody squeezed into the middle now.
Okay, so into the middle, how?
What's the maximum? Yeah, then we can know who.
Hold on.
Oh, you need a chair.
No, I changed that.
Okay.
It's very hard.
Okay. You need anything?
Okay, so we also have some food outside. So just for the people who stay here, just please together a bit. Yeah.
I can see both of the windows. And
Okay, then I think just next time, just like this.
but there are people here as well.
Yeah, just
I mean, just look at the camera. 1, 2.
Have a good evening, everyone, and see you next time.
You want to sign up for online video? You want to sign up for online?
And also for the online viewer. Thank you for followers on the stream. We will be sharing the slide of all the speakers on Force Asia channel. Thank you for your question, and see you next week. Bye.